24. All right. It says, now, again, for this right here, we're using a distance formula, correct? So that just means we're measuring the what? Lengths of the diagonals. That's exactly right. Now, it says to graph it, but what we'll do here is I'm just going to kind of rough sketch it just to make sure, like someone mentioned to me yesterday about the letters don't have to be in order. All right, so you kind of have to double check that. All right, but then once you establish where the rectangle is, then it's easy to see what the diagonals are. All right, so if I have 1, 8, oh, I'm sorry, negative 2, 2 would be somewhere around there, and that's Q. All right, and then 0, negative 2 would be somewhere around there, which is R. 6, 1 would be, looks like S, and 4, 5 would be up here, and that's T. So now you can clearly see the diagonals are what? Yeah, QS and RT. All right. So again, we're just going to measure QS. Now, again, guys, I think you guys are getting pretty good at mental math, so let's just look at this. QS is the square root. All right, from negative 2 to 6 is 8. 8 squared is 64, right? Plus, I went from 2 to 1, so that's 1, right?
Yeah,
1. Yeah, so that's just the square root of 65. All right. And then we want RT. All right, and RT, let's see what that is. So from 0 to 4, yep, squared, thank you, 16. And then negative 2 to 5 is 7, right? That's 49, right? And that's what? 65. So it's a rectangle because the diagonals are congruent. Are you okay with that? Any issues? Yes.
Can you do question number 11?
Let's try 11, please. Thank you. That's a good job. So it says AB is 6. Then it says AD is 2. Well, BD is the same as what?
A squared.
Yeah, but what's it the same length as? If I'm looking for BD, BD is the same as what? AC, right? And so AC is just the Pythagorean theorem, right? AC. You with me on that? So I'm thinking 436 root 40. So square root of 40, which I want everybody to make sure they remember is what? 2 radical 10. 2 radical 10. Come on, once again, I keep saying this. I think it's kind of easy. All right. If you're doing the work, it's really simple. All right, just ask me questions when you don't know something. What?
Where'd you get the room?
Because again, this is. Can you see the triangle that I'm drawing up there?
Mm-hmm.
A squared plus B squared equals C squared. Right or yes? Okay. I just feel like there's a bunch of. All right. Yes.
I have a question on 21.
All right. Let's check out 21.
Like, I get most of it, it's just one of the steps I have a question.
Okay. What was that?
So it says for one of them, it does QR plus RS equals RS plus ST. And then it does a different step. It does QS equals QR plus R.
Well, let's go ahead. It's kind of hard for me to, without seeing the exact proof. I did post the solutions, but I did. So let's just work it through. All right, let's just see if we can do this proof. All right. So what I'm going to do, I think it'll be easier if I just cut this and just put it down at the bottom somewhere. and then we can just talk about it. All right, and guys, listen, I'm kind of happy with the way the proofs are going. I think you're getting better at it. All right. And again, these are one of the things where if you didn't try it, all right, you made a mistake. All right, because you're not going to get better at them unless you actually try. All right, so let's see what it says here. All right, what I'm going to do is I'm just going to go ahead and, just in the interest of time, I'll come over here and we'll just do statements and reasons. All right, and then over here I'm just going to grab this. All right, and that's obviously step number 1, and we're just going to go ahead and write given down. All right. Now I'm trying to prove, now this is what I think is important. I'm trying to prove S, this triangle right here, and I think I allowed us to do the work on the iPad today. All right, so I just think this is helpful when we can do this. All right, so I'm going to move this triangle down here so I can see it better. And then I'm going to draw this triangle, because we're trying to prove those are congruent, right? Right, and this is R, T, V, and then we're just going to move it down here. All right? So right now, I can say what about those two things? All right, that everybody should be able to say. Now again, I think we're trying to find what? Side, angle, side, angle, side, angle, side, 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 those types of things, right? Now, does it say it's a rectangle?
Yes.
Yeah, all right. So right now, in my opinion, the quickest thing is to say angle T and angle Q are right angles. All right, I think we should say that. All right. Angle T and angle Q are right angles. And why is that? Good. Definition of a rectangle. Definition of a rectangle. All right. So now we can also say what? QW is congruent to TV, right? And that is again what? Definition of a rectangle. All right, so now I'm going to put this here and this here. I'm also going to have to mark QR, right? QR is equal to ST. You agree with that? All right. Now, I'm trying to get QS congruent to RT, right? So, yes, RS is congruent to RS. That's a reflexive property. But I could also say, let's just do this for now. Let's say QR plus RS is equal to what? QS, right? And then I'm just going to say that, I'll just do it in order. RS plus ST is equal to RT, right? And that, who remembers that? Good job, guys. Segment addition postulate. All right. Now, do we agree that QR is equal to ST, right? So try to watch now. I'm going to make that QR what? ST, right? So step 5. So ST plus RS is equal to what? QS. And again, we would say that what is what? Substitution, right? Now, what I'm trying to show you now is I think it's really important, so I'm going to highlight it again. See this step right here? And this right here. So now what's true? Do you agree with that? Good job, kiddo. So step 6, we would say, QS is congruent to RT, and again, that's just a what?
Substitution.
Substitution. So now we have this equal to this, and so now what? Triangles are congruent. I'm just going to abbreviate because I don't feel like. Triangles are congruent by what? Good job, guys. Side, angle, side. Does that help?
Yeah, for number 4, why couldn't you do RS equals RS and then QR plus RS equals RS plus ST? Because then you could just get rid of
QR plus RS. Say that again? I'm sorry.
QR plus RS equals RS plus ST.
But how did you do that?
Addition property. That's what they had in solutions. They had
Oh. Yeah, that's okay. I understand that now. I just don't think that way, right? So what's happening is this, guys. So watch. Here's what they did in the book. I understand now. QR is equal to ST or congruent, and then RS is congruent to RS. So then if you add that, you get QR plus RS is equal to ST plus RS. You agree with that? But I still have to say that QR plus RS is QS.
Oh, okay, got it.
You see what I'm saying, right?
Yeah.
So it's kind of the same thing. I just think I like my way better. Right? I just think it's to me more logical that way. Don't you agree? I think so anyway. But again, that's why it's kind of hard sometimes to follow your ideas. Right? If it's not the way I do it, then it's kind of hard for me to follow. All right, that's why I said we should write it down. Wow, that's pretty good, guys. All right, I think that's pretty good. All right. And like I said, if you didn't know how to do it, but you tried it, you're in good shape. All right. I'm going to pause and just collect the homework real quick. And then somebody do me a favor and see if I put this in Classroom. I think I put, yeah, because I think there's a lot of proofs, which again, about today is a rhombus. Does anybody remember what a rhombus is by any chance?
It's a square.
It is a square. That is what?
Oh, that's like this.
Tilted. All right. So that's a good job. So listen, is a square a rhombus? Yes. Is a rhombus a square?
No.
It could be if it has right angles. Hear me out now, because this is kind of confusing. All right. I don't think it's really that confusing, but all right. A square and a rhombus. All right. Every square is a rhombus, but not every rhombus is a square. All right. Now, the other thing that's kind of funny is a square a rectangle. Is a square a rectangle, guys?
Yeah.
Yes, of course it is. All right, because the definition of a rectangle just says opposite sides are equal and all the angles are 90 degrees. Everybody good with that? All right, so you have to be careful. I think on the test they ask you specific questions about that. All right, so you have to be careful that you know that. All right, now again, if you recall, I think this is on Classroom, right? Didn't I put it on Classroom? And the reason I put it on Classroom is because I want to show you real quick. Look at all the graphs. There's a lot of proofs here I want to do. All right, but before we get into that, I really want to go and I want to do something, and I want you guys to try to come up with all the different rules or all the special properties for squares and all the special properties for the rhombus. All right, so what does that mean? That means what's true about the diagonals. All right, what's true? First of all, is a rhombus a parallelogram? Is a rhombus a parallelogram?
Yes.
Yes. All right, these are all special parallelograms. All right, so everything that applies to a parallelogram also applies to the what? Also applies to the rhombus. All right, so opposite sides are congruent. All right. What do the diagonals do to each other?
Bisect.
They bisect each other. That is correct. All right. So now what I want to do is I kind of want to draw for you I want to draw a rhombus for you, and then we're going to try to see if you can tell me the different properties. All right. So I'm going to come over here, and I'm just going to do something like this. All right, I think I did a good job on that. I'll find out here in a minute. Oh, actually, that's not a very good job. All right, because that is a what? That looks like a what? That looks like a square. All right. So because that is a square, all right, we can just make some observations about that. We'll just go this way. All right. So first thing you need to do is it's a rhombus, correct? All right. All the sides are equal. Now, so let's mark it here, here. You guys don't have to do that. I really wish you would just watch up on the board. All right. I think that's good because I want you to try to tell me what's true. All right. So if that's a square, then what is true about the diagonals? What looks to be true? So I'm going to draw the diagonals in, and then we can kind of see for ourselves this. So what would that do to that square? What would the diagonal do to the square? What do you think?
Well, diagonals be congruent, so
Yeah, the diagonals be congruent, but first answer this question. If I just draw one diagonal,
two triangles
it creates two what type of triangles?
are isosceles.
Yes, there's the word, isosceles. All right, so now this is the type of stuff I want you to pay attention to because I try to tell kids every year it's just not possible to try to remember all the different rules for all the different shapes. Does everybody agree with that? Hopefully you agree with that. All right, like I said, some of you have good memory, so you just memorize everything and that's the end of the story. All right, but I would prefer that you not do that. I'd prefer that you look at that and say, okay, this is an isosceles right triangle. Does everybody agree?
Yeah.
So if it's an isosceles right triangle, then this right here is a what? Right angle. Now, what is true about these guys right here? They're equal. So what is their measure? 45 degrees. Is everybody with me on that? So they're 45 degrees. So if I make that 45 degrees and that 45 degrees, all right, then the other one is also what? 45 degrees and 45 degrees. So now, what is true about the diagonals of a square, or the diagonal of that square? What does it do? Tell me.
It cuts the angle
So instead of saying cuts it in half, we just say it.
bisects.
Yes. So please pay attention. The diagonal of a rhombus or a square bisects the angle. Was that true for a rectangle? Or was it true for a parallelogram? No. But if the sides are equal, it does bisect. Now, how do we know that's true? Well, we just kind of proved it true because it becomes an isosceles triangle, and the isosceles triangle means the opposite angles are congruent. Is everybody with me on that? All right, so that's how I'm trying to show you how you can figure this out. All right. Now what we're going to do is we're going to draw the other diagonal, and then you can try to explain to me what's going on if I go from here to here. If I go from there to there, what's happening now?
It cuts it in.
Yes, it cuts it into 4 triangles. And what's true about those 4 triangles?
Well,
They are all isosceles. What else? Yeah, they're all equal. How do we know they're all equal? Well, because the first rule is that if that's 45, then this guy right here is 45, that's 45, this is 45, and that's 45. All right? And we now can say that we knew already this was equal to this, but because these are 45, opposite sides are equal. Did I show that? Did everybody understand what I just did up there on the board? So he's correct. All of those triangles are congruent. All right. Now, what's true about the intersection of the diagonals. What's true about the intersection of the diagonals? Tell me. The angles add up to 360, but more importantly, each angle is,
A right angle.
say it.
90 degrees.
Yeah, they're 90 degrees. How did I know it's 90 degrees? Because I just added what? 45 and 45 together. Do I agree with that? And so that could be now what? The diagonals are actually perpendicular bisectors. They're actually perpendicular bisectors. All right. Now again, I think I just said a whole bunch about a square. A whole bunch. All right, is everybody with me on that? Now, what I'm trying to tell you is that there's a lot of rules there. And again, I just don't have them all memorized. All right, it seems like every year I just draw it out and I make sure that I'm correct with everything that I say about the square. All right. So again, there's a lot going on there that you have to know. So the diagonals of a square are definitely what? Perpendicular. They're definitely perpendicular. Is everybody okay with that? All right. Now, what I'm going to do is I'm going to try to draw a rhombus now. All right. I think I may have to go up here real quick. See if I can find one that's better. Yeah, so here's a rhombus. I'm just going to grab this rhombus and pull it down. All right, so we just kind of have to look at it. All right, so again, I don't really care that that right angle's there, all right? But I do want to discover that it is a right angle. All right, so how do we do that again? All right, let's draw this. These are congruent. Does everybody agree with that? And then what do we say about the diagonals of a parallelogram? They do what to each other? So right now I can say this is congruent to this, right? And I can say 1, 2, 3, 1, 2, 3. Does everybody agree with that? Now, are the diagonals congruent in a rhombus? Look, come on now. Don't shake your head. Don't listen to what your neighbor has to say. Look up there on the board and see if you think that the diagonals are congruent. Remember, if you're not sure, what did I tell you to do? Just tilt it more and more and more. What's happening as you tilt it? One's getting what? And one's getting, that's exactly right. So are the diagonals of a rhombus congruent?
No.
Are the diagonals of a square congruent?
Yes.
Are the diagonals of a rectangle congruent?
No.
Yes. Now listen, how I try to teach kids to remember that is if it's perpendicular, think of like a barn door or your door to your house. All right, measure the diagonal, right? That has to be what? They have to be equal. But as soon as you start to tilt the rhombus or tilt the rectangle, one diagonal gets what? Smaller and one gets shorter. All right, everybody good with that? All right, that's just one way to measure. All right, so now somebody tell me what's true about all four of those triangles now. What seems to be true about all four of those triangles that were created? Come on, speak up, join the class.
They're all equal.
They're all congruent. All right, is everybody good with that? There are four congruent triangles there. All right, now if they are congruent triangles, then what's true about this angle and this angle? They are congruent by CP/CTC. And if they're congruent and they form a linear pair, then they have to be what? They have to be 90 degrees. That's what I'm trying to get you to discover. Is everybody okay with that? All right. So all of these now are right angles, which means that these diagonals are perpendicular. All right, and they're perpendicular. Because we know that if this is congruent to this, what's true about this angle right here and this angle right here? They're congruent. So now the bigger triangles are called what type of triangles again? Isosceles. They're called isosceles triangles. And if they are isosceles, those two angles are congruent. Now, look up again at the top triangle. Is the top triangle and the bottom triangle the same? In other words, is this triangle congruent to this triangle? Yes. Because that's congruent, what's true about what do the diagonals do to the rhombus? What do the diagonals do? Come on, speak up.
Like perpendicular bisect.
Yes, they are perpendicular bisectors. All right. So what exactly does that mean? That means here, this angle here is equal to that angle there. Is that true for the rectangle?
No.
Definitely not. All right. Definitely not. But for the what? But for the rhombus, they are. All right. The diagonals bisect the angle. Now again, I just said a whole bunch of stuff, and we have a couple more shapes left to go. So I'm trying to show you, or trying to demonstrate to you, that there's a lot of information. I am not expecting you to have all of that listed out and memorized. I think you should draw a rhombus, draw the diagonals, and do it for yourself and see what's true about that. Is everybody okay with that? All right, I believe that's all I have on the square and the what? And the rhombus. All right, so let's go back and try a couple of problems. All right, fill it in now, guys. On notability is perfectly fine today, because there's a lot. So, if this is a rhombus, an angle BCD is 64. BCD. Well, is that kind of weird to somebody else? Does that look a little awkward to anybody else besides me? Why is that? It says angle BCD is 64. Why is that a little weird?
Because it's obtuse.
Yeah, that's right. I don't know why they would do that. BCD is obtuse, and they're calling it 64 degrees. All right, makes no sense. All right, but we'll just assume they meant ABC, but we'll just keep it the same. So if BCD is 64, then BAC would have to be what? Say it again. 32, right? Now again, remember, you got to find it to make sure. They're asking about BAC, right? Now what's true about opposite angles? They're equal. So that if I said what's BAD, you would tell me it's what? 64. But then they're asking about BAC, and we just talked about the diagonals of a rhombus do what? Bisect the angle, right? So BAC, then we're safe to say, is what? I think 32 degrees. Now it says if AB is 2x plus 3 and BC is x plus 7, what is x, somebody? What does x equal? Come on, that's mental math. Come on, guys. You guys will wake up. Help me out now. I'm not going to stand up here and do all the problems. I can just stop and you guys can do the work, or you can participate. So x equals what? 4. So if x is 4, what's the value of CD? Which one? Do you agree? 11. Yes, ma'am. Good for you. Because AB is congruent to BC. Do you know this? Right? And you just solved it. And then to find CD, CD is equal to BC and AB, right? All right. So write a 2-column proof to prove that if ABCD is a rhombus with diagonal BD, then AP is congruent to CP. All right, so that's our first proof. So I think I moved that down for you, right? Yeah, I went ahead and moved that down for you so we could do it. All right, so it wouldn't take as much time. All right. So here we go. I'm going to grab this. One, and this is what? Given. All right, so it's a rhombus. So if it's a rhombus, I would go ahead and mark what? Yeah, I would mark the sides congruent. I'm not sure if that's going to help, but I'm going to mark it anyway. All of those are equal. I'm trying to prove that AP, I'm trying to prove that this is congruent to this, right? So what am I going to have to do with those triangles? And prove that they are what? Prove they're congruent. And then if they're congruent, then they're what are congruent? By? Yeah. All right, guys, you're with me now. Come on. All right, so step number 2. Come on now. Someone join the class now. Go out on a limb. Try to answer a question. Step number 2. Come on. Some of you guys can never say anything. This is your time. Let's go. Thank you. What?
ADP equals CDP.
Angle ADP is congruent to, yay, good job. Angle ABP is congruent to angle CBP, and why is that? Somebody help him.
Definition of a rhombus.
Nope, definition of rhombus does not say that. We'll say it again. Come on, loud. What it? What is it? What is that line called? What is that line called? No. Thank you. I knew exactly what you're trying to say, but that line has a special name. It's not it. It's called the diagonal. All right, so again, I don't want you to have some explanation. I just want you to say what? Diagonal of rhombus bisects angle. Everybody agree with that? Everybody okay with that? So now let's come over here and mark it. This right here and this right here are equal. Now give me something else.
I was gonna say DB is congruent to
D. Now, but what triangle am I trying to get congruent? I'm trying to get this triangle here congruent to this triangle here. So there is a reflexive property involved, but not DB. What? Yeah. Yes, there you go, because that's part of the triangle. Some of you need to, if you're trying to state a triangle is congruent, highlight the triangle so you can see it. All right? So now, number 3, we say that PB is congruent to PB, and that would be reflexive property. All right, someone else who doesn't speak up. Come on, come on. Carson, what are you thinking about? Well, not yet, because I've only said 2 parts. We're missing 1. All right, let me show you real quick what I mean by that. I've only said an angle and a side. I'm missing something. It is marked, but I didn't. Yay, there you go. AB is congruent to BC. Why is that? Yep, definition of rhombus. All right. So now, step number 5, somebody. Gavin, come on.
Now you can say that the triangles are congruent.
Yes, you can. Good job, buddy. Triangle what?
Triangle A, B, D is congruent to triangle PBC.
You have to line them up properly now.
Oh, CBP.
Yes. C, B, P.
And that was
Why is that?
angle side. I think it's like, that was.
Yeah.
That was angle. Wait, side angle side.
Good. Side, angle, side. All right, someone else. Final step. Charlotte, go.
AP is congruent to CP because of C equals C.
Yes. AP is congruent to PC, CP, CTC. I just thought that was kind of easy. All right, hopefully you're getting better at it. All right, you're giving it a shot. Give yourself a chance. Or how much time do we have? Okay, so here's what I want you to do. I think these are easy. All right, and tomorrow I'll do the proofs with you and we'll classify them. Does everybody agree? So I want you to do tonight, which is just the algebra, 7 through 12 and 23 through 30. And then the other stuff will come back to class and I'll do that. Is everybody okay with that? All right, so this is a 2-day event. I thought it would be a 1, but it'll be a 2-day event. All right, so we'll finish up tomorrow. And then the next lesson is a 2-day event also. All right, and then we'll be ready to review. All right, good job today for the most part. All right, I'm almost done grading the homework that you turned in. All right, that had that quiz on it.